We're doing limits using trig identities. More trigonometry. Now, the identities are pretty tricky already, so I would recommend just pulling it up from like Google, just so you have like what they are. Didn't mean to do that. So you have what they are like readily available, and I would put these in your cheat sheet. Also, a lot of these are in your pre-calculus book towards the back cover, and I've shown you that from class. But if you don't have a pre-calc book, then you can always access it through like Google, and this is just Google images under trig identities. All right, so let's try our best with what we have here. All right, so I'm going to use the sine squared of, they have theta, I think, plus cosine squared of theta equals 1. And let's just double check. Sine squared of theta plus cosine squared of theta equals 1. Okay, good. All right, so that's what I'm going to use that to manipulate the cosine squared. Now, when I looked through identities, I didn't see a lot that kind of jumped out at me. But I do need to make sure that I get kind of cosine in terms of sine to try to cancel these out. Let's just make sure as we're doing these, we were trying to cancel. So if I plug in pi over 2 into sine, does that make 0? Now, I don't have mine memorized. So I just take a look at the sine curve. I have that memorized. And every pi over 2 is a special point. So here's pi over 2 right there. Pi over 2 has an output of 1. All right, so this is 2 minus 2, or 2 times 1. 2 minus 2 is 0. Yes, we can't have 0 on the bottom. So I'm trying to cancel this in some way. All right, now right away for my side work, I have that 3 out in front. I'm not going to worry about that. And on the bottom, there's a common 2. So that's not going to help me. I'm going to pull that out right away. 1 minus sine of x. All right. So I'm trying to get some sort of 1 minus sine of x going on here. And I'm going to use the fact that, so let's go ahead and solve for cosine squared. So I'm solving for cosine squared. Minus sine squared to both sides, minus sine squared to the other side, and I get cosine squared is equal to 1 minus sine squared of theta. Now, so this is a perfect square, this is a perfect square. These are a difference of perfect squares. So this cosine right here, so this is on the bottom, on the top, cosine squared is really equal to 1 minus sine squared. So 1 minus sine squared, and we're not using theta, we're using x in this problem. All right? So all I did is I changed out cosine to make it sine in terms of sine, in some goal trying to cancel these out. Difference of squares right here. 1 is a perfect square, minus sine, sine is a perfect square. So the right side turns into 1 plus sine of theta, in my case over here, 1 minus sine of theta. All right, so now I have, for this one right here, 3 over 2 1 plus sine of x, 1 minus sine of x, and there we are. So it just comes with practice and kind of working with these. So I know trig identities are tough. Just put a little time into it, bounce around, look through the hints, see if that helps you. 1 minus sine of x, and I have now gotten to a point where I can cancel out the issue. All right, so that means that all of this is basically equal to the limit as x goes to pi over 2. 3 times 1 plus sine of x. And on the bottom is just the 2. All right. And for sine of x, we're plugging in pi over 2. I already talked about that. I found it. It was 1. So when you plug it in, remember, there's no issues now, basically. So this would be equal to 3 times 1 plus 1 all over 2. 3 times 2. 2's cancel. 3. All right, 3. Okay. So the trick is you got to manipulate it in some way to cancel out the issue. Let's look at the next one. Excuse me. See how I would get started. All right, so we have a cotangent, and we have 1 minus sine. So I'm going to be looking for how is cotangent squared related in some way to sine. So let's go ahead and look. Cotangent. Cotangent. Cosine over sine squared. Maybe that's the one we want. Cosine over sine, and that gets squared on both sides. So cotangent is equal to cosine over sine. So cotangent is equal to cosine over sine. All right. Is that going to help? That's still going to give me 0 on the bottom. I'm trying to think of if I square it. Cotangent is really the tan inverse. So that's what I got over here already, tan inverse. Shoot. Let's do my side work. And like I said, it's just with this trig stuff, it's about experimenting and seeing what we can kind of get through to help us out. All right, so if I square all of this, that's cotangent squared, the same as squaring it. Square all of it. That square goes to both parts. All right, so this now becomes cosine squared of theta over sine squared of theta over 1 minus sine. These are x's, so let's go ahead and take care of it now. I'm not sure if I'm going down the right path, but that's the way this works. So I treat this as like a divide sign. All right, so that would be over 1. This is how I do it. So now I got all of this turns into cosine squared of x over sine squared of x. Divided by means I'm going to flip this and change it to multiply. So 1's on top, and 1 minus sine of x is on the bottom. All right, it looks like I'm going to do the same trick I did last time because I'm trying to cancel out this one. This one right here is the issue. If I just plug in pi over 2 here, I'm okay. So I need to cancel it out. So cosine squared. So sine squared of theta plus cosine squared of theta is equal to 1 minus sine squared of theta minus sine squared of theta. All right, so that now becomes, this is our, so 1 minus sine squared. 1 minus sine squared of x is on top. And on bottom, we got our sine squared x times 1 minus sine of x. All right. So, and then like we did last time, this is 1 plus sine, 1 minus sine. 1 plus sine of x times 1 minus sine of x. There's an x there. Over sine squared of x times 1 minus sine of x. 1 minus sine of x cancels. So that means all of this turns into the limit as x goes to pi over 2 and 1 plus sine of x over sine squared of x. All right, good. And then we're just plugging in pi over 2. So like we talked about last time, pi over 2 is equal to 1 for sine of x. So this turns into 1. This is 1 squared. And I get 1 plus 1 over 1. I got 2 as my final answer. Okay, so it's just kind of practicing, working through it, bouncing around. Notice it's a lot of work, but it's not too bad once you dive into these a little bit more. All right, so the first thing that jumps out at me is that double angle formula. So we got a double angle right here. And then here's that bottom. This probably is equal to, my guess would be like cosine, but double angle. So notice this would be like sine of 2 theta quantity squared, sine double angle formula. I don't have any of the double angles here. Looking for sine of 2 theta, sine of 2 theta. Sine of 2 theta is right here. Double angle identities. So like I said, just it's better if you use your pre-calculus book because everything's kind of laid out for you. But if you don't have it, kind of stuck using these. 2 sine theta cosine theta. And then this would just be cosine squared, and then I'd cancel out one of the cosines, and then that would kind of help. Okay, so just do your best, kind of going and treating each one with the whatever kind of identities you need to manipulate it.